Hi all, welcome to the next lecture series video of electrostatics. Last class we have learned about the charges and the properties of charges, and today's class we are going to learn about the next topic of electric charges and electric field. Ncert first chapter and first topic is over, and this is a second topic, Coulomb's law. Okay, so write down the heading on your notebook called Coulomb's law. Coulomb's law. Let me make it clear. Coulomb's law. So what is called the Coulomb's law? So Coulomb's law is similar to the law in which you have studied in your first year. First year also you have learned one law which is called the gravitational law, and this is also similar to your gravitational law, but gravitational law is applicable only for masses, right? Hope you have remembered the equation F equal to G m1 m2 by r square, Newton's law of gravitation. So this is also similar to that, but this is not related to mass, this is related to charges. We have learned about charges. Now we are going to analyze certain laws which are related to certain laws, certain properties which are related to the charges. So the first one is called Coulomb's law. What this Coulomb's law states that if we have 2-point charges, always remember the wordings I am telling. It's not like a collection of charges, or it's not like an extended charges. It's only one charge, point charges. If I have 2-point charges Q1, Q2 separated by a distance called R, then what Coulomb's law states that if two charges are having equal sign, which means either both are positive or both are negative, in that cases what will happen? These 2-point charges will be repel each other because they having either same charge or same charge in the sense either both are positive or both are negative, then repulsive force will be there. If two charges are having opposite sign, means one is positive, another one is negative, in that case there is an attractive force. So in both cases it is called force, whether it is attractive also or it is repulsive also, it is something called force. So what this law states that the attractive or the repulsive force between the two charges is directly proportional to product of the charges Q1 Q2 divided by R square. Product of the charges directly proportional to product of the charges and inversely proportional to square of the distance between them, and this proportionality sign is replaced with a constant called K into Q1 Q2 divided by R square. So what is this K? Here the Ke is equal to 1 divided by 4 pi epsilon 0. Okay, now you can have some similarity these equations with what you have learnt in gravitation also. Instead of K, what will come? Capital G, right? I am just writing here a similar equations. G instead of Q1 Q2, what you will write? m1 m2 divided by R square. This is the equations you have learned in Newton's law of gravitation. So it is exactly the same. Instead of G, K will come Q1 Q2. Here it is charge. Second year we are learning about more about electricity and magnetism, so it is charge. First year we are learning about the mechanics of physics, so there it is masses. So distance will be the same in the denominator. K is called 1 by 4 pi epsilon 0 in this equation. So I am rewriting this equations will be here. F will be equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. And now one important point will be here. F is depends upon how many factors? F is depends on epsilon 0 Q1 Q2 R square. Epsilon generally if you have writing one term called epsilon, then it is called a permittivity. So I am writing the word meaning will be here. It is called a permittivity. This is called permittivity. Here I am writing epsilon 0. This is called a permittivity of free space. Free space means our normal air medium only. So there is nothing wrong with this one, free space. It is nothing but air medium. Suppose instead of air medium, if you have something else or any other medium is available, then we'll say epsilon m. Medium in the sense other than air, other than the normal free space. If it is in a liquid medium, for example water, kerosene, diesel, petrol, if it is in some other liquid medium or some other gaseous medium, then the permittivity, this is called permittivity of a medium. It is not free space but some other medium, so which will have different values. So here this equation is generally written for an air medium, because you can see here epsilon 0. So here this F I can rewritten as F air. This is for air medium, or I can say free space, 1 by 4 pi epsilon 0 q1 q2 divided by r square. Now we'll write, if it is for a medium, then how we can write? I'll put it as Fm. Fm means medium, equal to 1 by 4 pi epsilon m q1 q2 divided by r square. Okay, this is for a medium. Now I am doing some calculations. F air divided by F medium. F air, this I am giving as equation number 1. This I am giving as equation number 2. So F air by F medium means equation number 1 divided by equation number 2. So this is actually the calculations I am going to do. F air divided by F medium, equations 1 divided by equations 2. If you are dividing 1 with the 2, what are the common terms will get cancelled? Q1 q2 by r square with the q1 q2 by r square will get cancelled. Here 1 by 4 pi epsilon 0, here 1 by 4 pi epsilon m. So I can written as F air divided by F medium equal to F air 1 by 4 pi epsilon 0 divided by 1 by 4 pi epsilon m. So 1 by 4 pi epsilon 0 and 1 by 4 pi epsilon m. So 1 by 4 pi and 1 by 4 pi will get cancelled, and rest of the equations I am writing here. So we'll simplify. We are just simplifying this, the final equations. F air by F medium. So 1 by 4 pi and 1 by 4 pi get cancelled. So what will come? F air divided by F medium is equal to epsilon m will go to numerator, right? Epsilon m, and epsilon 0 will come to denominator. Epsilon 0. This is something called epsilon r. This is called dielectric. Sometimes we call dielectrics, or we call it as relative permittivity. So more appropriate name is called, either we can say dielectric constant, we can also say dielectric constant. We'll learn dielectric constant more later, or we call it as relative permittivity. Relative permittivity. This is called relative permittivity. So more appropriate name, easy to remember, is called relative permittivity, because this is permittivity of free space, permittivity of a medium. This is something called relative permittivity. So I named this called relative permittivity. We can also call it as dielectric constant, but another term in the the next chapter, electrical potential and capacitor, there also we are learning one something called a dielectric constant. So you don't want to confuse between these two terms. So for that I will always stick with the name called relative permittivity, which is called epsilon m divided by epsilon 0. This is something called a Coulomb's law. Now we are going to see the now we know what is Coulomb's law. One shot, if you're asking, you will say 1 by 4 pi epsilon 0 q1 q2 divided by r square. That is called Coulomb's law. Now we are going to write down the next topic. Please write on your notebook the next topic, which is called vector form of Coulomb's law. Vector form of Coulomb's law. So vector form of Coulomb's law. Coulomb's law. Vector form of Coulomb's law. What this vector form of Coulomb's law will states that the vector form of Coulomb's law indicate force is nothing but which is called vector quantity. Okay, first year you have learned there are two type of quantities will be there. One quantity is called scalar quantity, another quantity is called a vector quantity. Okay, two types of quantity. What's the difference between them? Vector quantity means a quantity which will have both directions and magnitude. For example, I am applying a force to close the door. So I will suppose I am closing the door like this one. Then you can say I am applying some force in this direction. Suppose if I am opening the same door, then I will pull it like this one. So in that case I am applying the force in this direction. So force will have a magnitude, how much Newton force I have applied. So it has a magnitude. Along with that it has a direction also. So that's what Coulomb's law will comes in a vector format, because force is involved and force is a vector quantity. Now we'll see how the things are going on under this topic. As like we are starting, like we have two charges will be there, q1 and q2 charges are there. Okay, Q1 and Q2 charges separated by a distance called R1. You can consider either it is a like charges or it is an unlike charges. Okay, so now at present for starting I am assuming both the charges are like charges. If both the charges are like charges, then what will happen? The Q1 will have an influence of Q2. Okay, so both are positive charges, so Q1 will be here as such and Q2 will be here. Both are positive means what will happen? Q1 will move towards Q2 or away from Q2. It will move away from Q2. Why? Because both will having the same charges will be here, so same polarity will be here. So the force on, listen very carefully, force on charge number 1, force on charge number 1 like this because of charge number 2. So I can written as force on charge number 1 because of 2. So it is called F12. Okay, similarly force on charge number 2 because of 1, random positive one. So what will happen? Q2 will move like this. Correct? Q2 will move. So the force on charge number 2 because of what? Because of 1. So F12 and F21 are in opposite directions. What will happen if both the charges are like charges? Here I can see both are like charges. Both are like charges, which means positive or positive not positive, or it is the another charge is called negative. Both charges will have either positive or negative combinations. Suppose we are assuming one is positive and another one is negative. So what will happen? Suppose I am assuming Q1 is positive. I am drawing here Q1 is positive and Q2 is negative. So this is positive and this is negative. What will happen? Q1 will experience a force. What type of forces? Attracting towards Q2 or repulsive force? Definitely you know it is an attractive forces because both are having opposite charges. So Q1 will attract towards Q2 with a force called F1 because of what? Because of 2, F12. Next, the same way F2 will have a force towards Q1 because it is positive. So negative will attract towards positive. What type of force? F2 force. This F2 force is coming because of which charges? 1. So F21. Now if you analyze will be here, the difference between the two cases is what? Both cases, if both are like charges, the repulsive forces are acting in opposite direction. If both the charges are I am writing here just to opposite, like both are unlike charges. If both are unlike charges also, you will get two forces. Now there is one similarity between both are like charge case and both are unlike charge case. What is the similarity between these two? If both are like charges means the forces are in opposite direction. But if both are unlike charges also, forces are in opposite direction. So always in Coulomb's law cases, the force between the two charged particle is always in opposite direction. So either it is a like charges also or it is an unlike charges also. Forces are always in opposite direction. Either both are moving, as like in the second case both are moving like this one, or as like the first cases both are moving away from each other. So there are two cases will be there. Okay, so understand this concept. Based on that we are going to derive some formula, some equation stuffs will be here. So I will take the first cases. So both cases are same. Now you understood, right? So both will have applying a force and both the forces are acting in opposite direction. So I'll stick with this one, first force. So I'm writing F12, force on charge number 1 because of charge number 2. It is a vector quantity. We are writing 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. Here before we are going to write it to R square, I am writing R square will be here. So this is whole parameter is nothing called a magnitude. So a physical quantity, if it is a vector quantity, it should have magnitude and direction also. So this has magnitude but no direction. So I have to specify the direction also, right? So it is from where to where. So force on charge number 1 because of charge number 2. Okay, force on charge number 1 because of charge number 2. So it is actually from 2 to 1. So 2 to 1, right? Force on charge number 1 because of 2. So it is 2 to 1. So R21 cap. Okay, this is called unit vector. You know unit vector having magnitude 1. So this is a quantity if it is multiplied with a quantity having magnitude 1. Suppose this you are assuming a number called 26. Then you are multiplying 26 with 1. This value is called 1. So 26 into 1 means how much? This 26 itself. It's not changing. So this is only giving the directional parameter only. So this is directional parameter. Now we are writing f12 vector equal to 1 by, here also I forgot to mention, here also it should come what? R2 1. So 1 by 4 pi epsilon 0 q1 q2 divided by r21 square into, how we can write a unit vector. Normally in the first year vector class you have learned vector n equal to a vector divided by magnitude, n cap equal to vector n divided by magnitude n. Similar way this r21 we can say r21 vector divided by r21. Okay, this is a magnitude value. Now if you multiply this one, what will get? F12 will be equal to 1 by 4 pi epsilon 0 q1 q2 divided by r21 magnitude. It is square, here it is power 1. So altogether 2 into 1 it become totally 3. So it is r21 modulus r21. So it is a magnitude parameters will be here r21 square with r21, totally r21 cube. One vector will be here r21, it's a vector notation. So this is the equations for f12. Here I would like to convey one more important point. What is called r21 vector? If a vector will have 2 points, first point this is called starting point, this is called ending point, because it is r21, force on charge number 1 because of 2. So because of 2 means we are coming from 2 to 1. So if you are writing a vector r2 to 1 means 2 is an initial point and 1 is the final point. So always we are writing vector final point minus initial point. Where we are reaching on charge number 1 because of charge number. So from charge 2 we are starting and charge 1 we are ending. That's why we are writing r1 minus r21. The same way how we are writing f12, can you try to write f21 by pausing the video for next 5 minutes? Okay, you can pause the video for 5 minutes. And how I have written for f12, here vector notation is mandatory, now you understood how I have written f12. Okay, do not think like okay here it is 1 2, here it is 2 1, do not by heart like this one. Understand the concept, pause the video and write yourself. Okay, then I am continuing here, you can pause it and you can write it. I am continuing, you can just pause it and you will come back. We'll know now if you have written the equations correctly, you will get f21 will be equal to 1 by 4 pi epsilon 0 q1 q2 divided by, how it is coming, r12 cube into r12 vector notations. If you are getting like this one, then your answer is correct. r12, what is the value of r12 similar to this one? We know r12, vector r12 equal to vector r2 minus of vector number r1, vector r2 minus vector r1. Now you understood the two equations, how it is coming in vector format. If it is in vector format, denominator cube varum, here vector signs will. So this is just indicating the direction. So while you are writing in a vector format, the first step is always you have to write the magnitude, then you have to multiply it with a unit vector. So f12 and f21 both are always in opposite direction, as like I told before, either it is an attractive force or repulsive forces, both forces are in opposite direction. Okay, hope you understand. F12 I described, f21 you have written yourself. Okay, and we'll move to the next topic. Next topic is superposition principle. Write on the heading, superposition principle. Superposition principle. What is the superposition principle? Superposition in physics, not only here, in the further chapters, if you are going ahead of the chapters, wherever you see the word called superposition, you just assume it is called summation, addition, that's all. Okay, I'll tell you a simple example here based on this. Suppose I have a charge called Q, capital Q. Okay, suppose I have a charge called capital Q. I am assuming it is positive. I have another charge called Q1. I have another charge called Q2. This is negative, this is negative. Now if somebody will come and ask you understand the concept, I am telling the concepts. So what is the force on the capital Q? So I can say, based on the vector notation, force on capital Q because of Q1. One case. Tell me the formula. 1 by 4 pi epsilon 0. Tell me capital Q, Q1, Q2, capital Q and Q1 divided by the distance between them. I am taken as x1, and the distance between these two I am taken as x2, just for our understandability. So this will become x1 square. Okay, so if you are writing in a magnitude format, so we know it is from capital Q to this format, right? And this is the vector distance. So I can written as x1 cube and with the vector called x1. Okay, similarly the force on charge number capital Q because of Q2. Tell me the formula. You know, now you know, all of you are telling, right? 1 by 4 pi epsilon 0 capital Q, Q2 divided by, what is a vector distance called? X2. In vector format, if you are writing in a vector format, then cube will be here with multiplication of x2 vector. This is one way. If you are you can also write the equations in another way. I am writing parallel to this one. This equations you can written as 1 by 4 pi epsilon 0 capital Q, Q1 divided by x1 square into x1 vector. X1 cap. X1 vector means x1 unit vector. Similar way, here it is not x1 unit vector. This is a vector. If it is vector means here cube will come. You know, unit vector equal to vector s1 x1 divided by x1. So already one square will be there, that will multiplied with this denominator x1 magnitude, so it become x1 cube. So this is an alternate format. Can you tell me what is this for? 1 by 4 pi epsilon 0 q into q2 divided by x2 square into x2 unit vector. If it is vector means, as I told before, you will get a cube. If it is unit vector, like this one. Now can you tell me the direction of the forces will be here? F capital Q Q1, F capital Q Q2. This capital Q will attract, right, towards this direction. So I am marking just the force directions. I will take another color. So based on that I will mark this one, capital Q with the Q1. Okay, what forces? It is towards the right side. This force will happen. So this I am writing F capital Q Q1. Similarly with the Q2, it is also attracting like this one, F capital Q and Q2. Both the resultant forces are in the same direction. Now what the superposition principle is talking about is, if both forces are acting in the same direction, I mean again the same line, either through x-axis or through y-axis, whatever, so but always in a same line. If it is acting on a same line, then you can add it up. You can say total force on charge number Q, total force on charge number Q because of Q1 and because of Q2 will be equal to F capital Q into Q1 plus F capital Q and small q2. This is the equation of this one. F capital Q equal to FQ Q1 plus FQ Q2. Why I am adding like this one? Because both are in the same direction. If it is are in the same direction, you can just sum it up. That is called the superposition principle. I'll tell you one more cases will be here. That is very commonly asking for entrance examinations. The same cases, the same diagram, I am redrawing it in another way, like Q1 and Q2. This is negative sign, this is negative sign, this is positive sign. So what will happen? Now our Q1 is like this, Q2 is like this. Both are in the same direction? No, both are not in the same direction, right? Both are not in the same direction. Both are like this, like this. So one force will be like this, another force will be like this. But we have to know, or the question has to given the angle between the two forces called theta. If something is given like this one, here the forces are not in a straight line. Here forces are in a straight line means we can add it. If forces are not in a straight line means we cannot add it. To find that resultant force, at least I hope you have remember maybe something like this one. Root of, you have remember, right, resultant of 2 vector in first year, root of a square plus b square plus 2ab cos theta. You remember, right? The same formula we are applying here, but a square b square are the 2 vectors. Okay, so instead of a square and b square, here I can say this is called a, here I can say this is called b. So a square b square plus 2ab cos theta. So I am writing here, first I am writing the general formula so that easy for you to remember. Normally the equation is called resultant force, resultant vector equal to 2ab of cos theta. Now here total force resultant is capital Q, and this is equal to root of F capital Q into Q1 square plus F capital Q small q2 square plus 2 times of FQ Q1 FQ Q2 into cos theta. What is called theta will be here. Theta is the angle between FQ Q1 and FQ Q2, and this angle is called the angle between this is just one line like this, this is another line like this. So the angle between these two lines is called theta, and this theta is this one. So this is nothing but angle between two things. So superposition principle will have two aspects are there. If the forces are acting on the same direction, you can blindly add it, and if forces are not acting in the two directions, definitely you have to apply this formula to find out the total force. So total force to find out, we have two formulas are available. Forces are in the same direction, you can just add it up blindly. If forces are not in the same direction, you have to do this calculations. Understood? This is something called the superposition principle. This is called the superposition principle theorem. Next we're going to do some comparisons with, now we know what is called Coulomb's law magnitude format, Coulomb's law vector format, we know superposition principle also. I will tell you one more examples with the superposition principle, then we'll move to the next topic after that. We'll see. I'll take one example for this one. Let's see. I have a square, for example, I have a square structures are like this one. Here we are just describing one idea, that's all, to understand the superposition principles. I have a plus 2 microcoulomb forces will be here, and I have a minus 2 microcoulomb forces will be here, and I have a plus 3 microcoulomb will be here, I have a plus 1 microcoulomb will be here. My question is, I want to find out what is the force on charge number 2, force on charge number 2 because of all other charges. So I want to find out this concept is force on charge number 2 because of other charges. Okay, so 2 is our attention, right? 2 is our attention, we want to find out force on 2. So because of 3, what will happen to 2? 2 will attract or repel, correct? 2 will repel like this one. Because of this one, what will happen to this 2? 2 will attract towards 1 or repel from the 2 one? Repel. So 2 will move like this one. Okay, so there are one forces will be here. Next, so this forces I am writing as force, this force I am writing as force on charge number 2 because of 3, F2 3, and here force on charge number 2 because of 1. Okay, now I have minus 2 microcoulomb on 2 microcoulomb. What will happen? This 2 microcoulomb will come like this because it is opposite sign, this will attract. So I have one force. What is this force called? Force on charge number 2 because of minus 2. So I am putting like this. F2 or minus F2 minus 2. I am giving like this one. So now we'll see what will happen. Now I have 3 forces will be here, but 3 forces are in 3 directions. What should I will do? I can club any 2. Okay, I can club any 2 means I know these 2 forces. What is the angle between the 2 forces? 90 degree. So I can find out the resultant of the 2 forces. Next, you forget about this force for a moment, because at a time we can only apply all our superposition principle for a two forces. If both are acting in a different direction, we have to find the resultant, we have to find the total effect of that one, then we'll see. So if you find the total effect of this one, what will happen? F23 and F21 both are acting with an angle of 90 degree. What is the formula for the resultant forces? Resultant forces will always act like this, one, and these forces I am writing as F2R, just for my understanding. F2R I am writing. Next, what is called F2R? F2R will be equal to root of of same formula, a square plus b square plus 2ab cos theta. What is a? This you can consider anything as a, and the another one is b. So this is a and this one is b. So f21 square f23 square plus f21 square f23 square plus 2f21 f23 into cos of 90. Into cos of 90. What is cos 90? Cos 0 is 1. Cos 90 is 0. So this terms will go. So what is the resultant force will be here? F21 square plus F23 square. Cos 90 terms go on. So now this term and this term I combine, I will get a total effect. I'll get a total effect in what direction? Along this direction. Okay. So far I have not considered this one, right? Now this force you can forget, but this force and this force total effective we find out. Okay, now you can forget about these two. Now we have this force and this force. If these two forces are in same directions, what you can do? You can add it up. If these two forces are in same direction, no, these forces are in opposite direction. So how you will find the total force? So total force on charge number 2 is equal to, two forces are in opposite direction. You can subtract higher value minus lower value. That's all. You can subtract like this. Suppose I am assuming F2 minus 2. This is one force minus F2R. You can also do like this. So I got a minus signs will be here because both vectors are in opposite direction. If both vectors are in same direction, as I told just 5 to 10 minutes before, then you can add it. If both vectors are in opposite directions, you cannot add it, you have to subtract it. So what concept I used will be here? I used the two principles what I have learned from the superposition principle. If both vectors are in the same direction, I can add. If both vectors are in the opposite direction, I have to subtract. If both vectors are in opposite direction, not opposite direction, with some angle, then I have to find the resultant of the two vectors. So once you find the resultant, these two are going out of scope. You only have this one, and this you have to combine with this one. If these two forces are same direction, you can add. Now these are opposite direction, you can subtract. You can subtract this way, or also some people can also do like this one, right? F2 and minus 2. You can also do like this one. Now we'll assume if say a student A is doing like this one, student B is doing like this one. Can we say both are correct or both are wrong? Both are actually correct. But what is the difference is like F2 minus 2, this force minus of F2R. If you are subtracting and you are getting a positive number, for example, positive number. If you are getting a positive number, what this indicates? This is a higher value, this is a lower value. That's what you are getting a positive number. If you are getting positive number, then the total force on 2 is acting in the same direction of F22. Suppose if a one guy is doing like this one and he subtracted F2R from F2 minus 2, then you are getting a negative number. When you are getting a negative number, you are subtracting a smaller number from a higher number. This will be smaller, this will be higher. You are getting a negative sign. Negative sign means this is in the direction of F2R. Understood? If it is a positive number means, okay, how you get a positive number? This is a higher value, this is a higher value. So if it is a positive value means because of this higher value is subtracted a lower value subtracted from this higher value, you are getting a positive number. If you are getting a positive number, this will be in the F22 direction. Okay, in another case, if you are getting a negative number, then in F2R directions. So you can do it either this way and also this way. A student A will got one answer, student B will got same answers, but with opposite sign. If your sign is opposite, if your sign is positive, then your net force, the final force, is in the same direction of your first quantity. And if your answer is negative, then your final force will have the same direction of your second quantity. That's the only difference. So hope you understood what is called the superposition principles. Okay.